So you can then decide how many grid points in the total time t. Say for example, you can try to say, okay, I'm going to simulate for say 1,000 uh, intervals, so that then the code that we're going to write will try to locate the locations of the particles from the beginning of 0 to t last for 100 time steps. So the n can be made to be 100 or to be 200, 300. If you find that the simulation is not correct, then most probably you would have to increase the numbers of interval in your time grid. So let us try to begin our simulation. Before we begin, first of all, you have to have the idea first, the algorithm. So once you understand the algorithm, then you can try to translate the algorithm into the form of the Python code. Okay, I think the first, the simulation looks something like this. The algorithm is like this. So let us look at this one. So first of all, you assume that you know what is the initial position of the location x and also x naught dot, which is the velocity. So given these two at n equals to 0, where n is the numbers of time step, then you first calculate the locations of the position at the next time steps. So t plus delta t means it is the locations of x at the time step of n plus 1, and you begin the n from 0. Then this refers to the locations of the particles at the previous steps, which is sometimes written as x of n. So here we're going to use n to denote the time step, and this t is to be expressed as in unit of step, such as that t is equal to n, the number of time step, times delta t. Okay, so delta t is just the delta t or the resolution of time t in the time grid. So in this case, your delta t would be then just simply equals to the t last divided by the number of grid points between them. So the locations of the position x is calculated based on the previous location of x times the product of the velocity of the the velocity of the particle multiplied with the time step delta t plus the contribution from the acceleration of the particles. And this acceleration a is to be obtained from the equations of motions. The equation of motion actually tells you what is the accelerations. So in the case of this simple harmonic motion, the acceleration is known if you know what is the location of the particles. Once you have calculated the location of x at the next time step, then the next step to do is to calculate the acceleration at the next time step, which is also could be easily obtained from the equation of motion. Once the x in the next time step and the acceleration at the next time step is calculated, then you calculate the velocity of the particle, which is the x dot at the next time steps. So the x dot or the velocity of the particles at the next time step is again depend on the previous velocity and add with the average of the acceleration comprised of the accelerations in the previous time step and the next time step. Multiply with the delta t. So let's see how we do this one by one.